What's going on, everybody? It's Mr. Gustin. I'm in the physics conference room. Today, we are going to be clarifying some things for us. We've got these four kind of vocabulary, 4/5 kind of vocabulary words we've been using this unit. They are over here. They're force, electrostatic force, electric field, electric potential energy, electric potential, change in electric potential energy, and potential difference. And these words oftentimes get confused in our brains as we're thinking about these things. So I want to take a time, make a video to explain this for us. So let's start with what I think is the most basic example, two charges. I've got a positive 5 Coulomb charge and a positive 1 Coulomb charge. So let's go ahead and talk about what's happening with these two charges and the information we can gather from these two charges, all right? So if I've got these two charges, they're both positive, I know that they repel each other, that's Coulomb's law. I can actually determine the magnitude of that repulsion using Coulomb's law. So with two charges, they both experience an electrostatic force. And I can go ahead and say the force between these two charges is Coulomb's constant times the first charge times the magnitude of the second charge over r squared. And again, these things are separated by a distance of r. I can actually calculate the force that these two charges will experience. Okay? I can also calculate, and this helps me figure out the acceleration of a charge, if the charge is going to end up moving, what that acceleration will be. What I can also calculate from that is the electric potential energy between the two. That's K, Q1, Q2 over R. And if you think about this, it's like, well, force times distance is work or energy. And so if I multiply this equation by a distance value like R, I end up with this equation here. So both of these equations, both electrostatic force and electric potential energy, are things I can calculate and information I can find out from two charges. I can also go ahead and then move these two charges apart and figure out what is the change in electric potential energy. We can call that work done. So these are all things I can determine from two charges. Now, it would be awesome if in every example I have two charges, right? I know the exact amount of charge in both objects. That's not always the case, especially with batteries. I know like the size of the battery, but I don't exactly know the total number of charges in a battery. It's relative to the chemical reaction going on inside it. So instead, we have to have a different way to quantify these things if we only know one charge, not both charges. So let's imagine we get rid of one charge and we're down to just this, just my 5 Coulomb charge. So not two charges, now we only have one charge. Well, with one charge, I can't find the electrostatic force, but I can predict what it might be at a certain distance. For example, let's say at a point P, I can go ahead and draw what the electric field might look like out there. The electric field is my one charge equivalent to force, because what the electric field tells me is the force, a charge, really a positive charge, we'll say a positive charge, would feel. If it were there, that's what it is. And that's why E field is measured in newtons per coulomb. So if I did end up finding out the amount of charge that existed at point P, I could use my E field to determine the amount of force per coulomb. This is what the E field does. It predicts the direction and the magnitude of a force at a location that I don't know yet. This is what it does. It's our one charge equivalent to force. Well, then I wonder what voltage is, or electric potential. Well, electric potential, like the name implies, is related to potential energy. If at that same point exists an electric potential. If the point was there, we could calculate electric potential energy, but we don't know what that charge is, so we can predict it using voltage. Voltage is equal to K, Q over R. This is our predictive value. It will predict if there is a charge at point P, how much potential energy would exist between these two things. This is why it is measured in joules per coulomb. It tells me how much energy would be there given a charge of a certain value. It's a ratio, it's a predictive value, okay? The last thing we have is a change in potential energy. As if I was to move this charge from here to here, and I wanted to find that change in potential energy, but again, I only have one charge. And because I only have one charge, I can't actually calculate the change in energy. So instead, what I calculate is the potential difference, or the change in potential. How do I do that? I can use this equation here. I've got all number of equations I could possibly use to find that potential difference. But that's the difference between two charges and one charge. When do I use E field, electric potential, and potential difference? When there's only one charge present. When do I use things like force, electric potential energy, and change in potential energy? I need two charges. I'm hoping this starts to make sense in our heads why I would have these different things and what they mean for us. Just remember, E field is related to force, potential is related to potential energy, and then potential difference is related to the change in electric potential energy. Okay? If you got questions, drop in the comments, ask me in class, or send me an email. Until next time, see ya.